Greetings, it's windy, so we're going to pick up some wind noise today on this microphone. Unfortunately, it's just how it goes. We're going to do something fun today that doesn't have to do with apples. Alright, so here's the background story. I need a sauna. I've been taking 3 to 5 saunas a week, and I'm pretty sure that's the thing that has most helped me feel better and have way more energy. You know, why that is, that's another story, so I won't go there. But I've been putting blankets up on the end of my kitchen trailer where the wood stove is and just blocking it off and then cranking the fire up in there. It's starting to smell like a locker room in there, and it uses a ton of wood. It's just so drafty in there, and the space is too big and everything. So I want to build a small sauna that could fit 2 to 4 people. I haven't really designed it yet, but it will definitely be wood fired, but something that will be a little bit more efficient. And I don't want to put in a regular wood stove. For one thing, it's going to be super small, right, in there. And if I have a small space like that, I don't want to take a bunch of it up with a big wood stove. Small wood stoves are very uncommon. The ones you can buy are usually very expensive. I have 2 here on the property, but they're both in use, and they're still too big. You know, they're oversized for this use. So I thought, okay, it'd be better if I designed a stove, and I would like one that I can extinguish if it's not all the way burned up. Say I light it, I do my sauna, and I'm done. It's 40 minutes later, and there's still wood burning in there. I'd like to be able to put it out really easy so I can save the charcoal. Now, as much as I would like to take, a week to design and fab and experiment with this, I need to do it pretty quick. The first idea I had was to use a TLUD. TLUD stands for top lit updraft. Let me show you how those work and why I would want to use it. Okay, a top lit updraft stove is filled with something like small pieces of wood or wood chips. I'm not sure what kind of fuel I'll be able to get away with. That'll just be a different part of the experiment. So it's filled with fuel, and then it's lit at the top here. Pink chalk for fire. We're going to light it at the top. I think it's best to have some kind of lid with a draft, like a stovepipe or something, to help draw air. Okay, so now the air comes in through the bottom. Say you get a draft going, we have a fire up here, and instead of a usual fire which you light at the bottom and the heat travels up and the burn zone travels up like this, we're going to have a burn zone that travels down. So we got our air coming through, it hits the burn zone. As this goes down, the oxygen that's coming in is used up. So there's no oxygen coming in up here at all. So as this up here starts to turn into coals and charcoal, it just goes out because it can't get any more oxygen. So you have charcoal that was burning up here, but it's being starved of oxygen to the point where it goes out, and the hot air, very, very hot air going through here is not enough to burn it. Because it doesn't matter how hot you get this charcoal, if there's no oxygen, it's not going to burn. This will just keep traveling down like that and leaving a thick layer of charcoal up here. When the burn zone finally gets down here, and this is all full of charcoal, now the burn zone will finish burning, turn into ash, and then the burn zone travels back up, and this all will keep sinking, and it'll just burn the whole thing into ash. So it's kind of like a 2-part thing here. Think of the advantages if I'm doing a small sauna, right? And I'm only going to use it for a short amount of time. If it's efficient enough and I can size this container right, this fuel cell, there's a good chance that I can burn this to somewhere in here and then just extinguish it when I'm done. And then it'll just go out, and next time, later, or even next time I use it, I just pull out a canister or something, dump out the charcoal, refill it, put it back, and light it again. The other thing is that if I have a really small space, I would prefer not to take up any space inside the sauna for this. So now I'm thinking, well, this is going to be a small building, so I'll pierce the wall with a 45-degree angle pipe. Let me draw out what I'm thinking. And we're basically looking at the back wall of the sauna. So what if I put this outside at something like maybe a 45-degree angle? I have this be a large insulated pipe, so it's not going to catch the wall on fire, I mean, we'll take precautions for that, for piercing this wall. So this will actually come through like that. We'll slip in a canister here made out of a smaller piece of stainless stovepipe. I don't know. I have a feeling this is going to work, but this is a total experiment, so we'll see. Okay, so this is full of fuel. Easy to take in and out, right? It's like a canister. You can prepare it ahead of time. You could have a second one ready. You could have a bunch of them ready, whatever. This is our air inlet, so I'll have control here so I can shut this off and not have any more air get in. And then on this end, we'll have a bare stovepipe that's not insulated, because virtually no heat is going to escape the system in this area right here. Not enough to matter. So once I get in here, we'll see what I can get away with. I would like to have like a really long stovepipe path, but it may be enough to just continue the stovepipe at like a 45-degree angle like this or something across the back wall. Obviously not touching the back wall. The back wall will be metal. Again, I'll take precautions regarding like fire safety and all that. And let's say we go here and then go through the roof, or we go out the side of the wall or something like that. Also, I'll have a shut off here, like a gate, basically. So gate here. So when I'm done, I just turn this off. I would have this canister, maybe leave like an extra 3 or 4 inches at the top here without any fuel in it. Put in like a piece of some kind of fuel, like maybe just a piece of crumpled newspaper or something. I don't usually use newspaper to start any fires ever. But in this case, that might be the best option. But something that you're going to be able to light that's going to go really fast and immediately create this draft going this way. Because we want, like, here, let me be consistent with my colors here. So pink is fire, blue is air. So we want, like, you know, to establish this draft really quick. And this is like 45-degree angle, so it might be a little sluggish. So often, like with a rocket stove or any kind of stove, if you just want to establish a really quick draft, you just take a crumpled piece of newspaper, light it on fire, and like stuff it into the stovepipe, and that'll often just kick it right off. But whatever that takes, you know, establish the draft. We'll have to have a way to keep the air from traveling up these sides, like some kind of gasket or seal down here. I think there is potential to take this and maybe angle it, go across, even back and forth, who knows? I mean, a lot of that is going to depend on how clean this system burns, because I think it's going to burn super clean, but I don't know that. If it doesn't burn clean, this isn't going to work well, because this pipe's going to fill with creosote. The creosote's going to drip. It's going to like create a fire hazard inside the pipe with the creosote. So I need this to burn pretty clean, and I just don't know how clean it's going to burn until we set it up and try it. All I have inside is this and this. So I don't have a messy wood stove. I don't have to have a wood stove like on the floor. Like let's say I did this, where I'd have to like take something apart in order to like put a canister in from the top, right? I can, if I'm out here, hopefully I'll be able to slip this in here. So I keep all the mess, all the wood outside. I have a canister that's easy to slip in and out, that I can prepare ahead of time, so I can have a number of them if I want. It makes charcoal, and hopefully it'll burn clean. These usually need like sized fuel, right? You can't just put in like one big chunk of firewood and slip it in there and light it. It's got to be like graded sizes of fuel. So we'll see what we can get away with. Like probably I would think nut shells would be good. I have a whole trash can full of walnut shells I've been saving for something just like this. You know, it may require that I prepare wood carefully, like slice it into 2-inch pieces and then chop it into little blocks or something like that. Axe wood chips would be good. I could just pick stuff up. I may be able to pack this full of like branches or twigs or something like that. That might work, but we'll find out. But whatever it is, it's going to require some doing to prepare the fuel ahead of time. But remember that I'm not using, hopefully, large quantities of wood. I'm thinking this is going to be like up to 2 feet long max, between 6 and 8 inches in diameter for that canister. So it's not going to take a whole lot to fill that. Okay, so today what I'm going for is simply a proof of concept. Does this work, essentially? I need a reasonably long section of insulated stovepipe at either 8 or 10 inches. And I want all this to be stainless eventually because carbon steel will burn out, like especially this insert with the fuel in it. That thing would burn out super fast if it's carbon steel. I need enough 6-inch stovepipe to create like a draft here, so we can get a good draft pulling air in from here. I need an insert that's going to be somewhere between, I'd say, 18 inches and 2 feet long that's going to fit in here. I mean, for testing today, it doesn't need to be stainless, but eventually. And I will need to put some kind of screen here to hold the wood chips in, maybe just a piece of hardware cloth or something like that. Really, it doesn't look that hard, and I need a way to prop this up at like about 45 degrees in order to test it, and that's all we need today. If we can get that set up, I can get an idea of whether this is going to work or not. So let's strap on the action cam and just go look for parts. I have some 8-inch metal Bestos pipe here, but I also have this 8-inch pipe. It's stainless. This section looks like what I need right there. You know, this is 8-inch, so that must be 10-inch. Wow. How cool is that? So that's really, it's like, it looks like it's 9-inch, which I didn't even know. I don't think that's really a standard size. That's kind of perfect, because I can find like an 8-inch piece of stainless. Yeah, this looks good. You know, we think about, you know, like piercing the wall and then having a good section on both sides that's, you know, basically heat proof. It's not going to leak much heat out. That looks about right. I feel like there's more of that stuff back here. Ooh, look at these. How big are these? And I have like a whole bunch of these soda kegs. They're called soda kegs or corny kegs. Dang, dude, that is just perfect. So all this rubber up here, this is just, yeah, that can be removed. It may not be easy, but it can be removed. And then this end has this little kind of door thing going. So, you know, that may be useful for part of this or not. But as far as like a canister that's the right size, exactly the right size, amazing, nice solid stainless, dude, how cool is that? Okay, I got a little head scratching to do here on whether I really even need this. I thought that having this, you know, in this insulated tube might help keep that burn zone really hot and improve the performance and the draft and the heat at which it burns, but I may not need that. I might be able to just kind of prop this thing up and put a stovepipe on it for a draw and see if that works. So let me think about that. We're getting into this back shed here to see if we could find any stovepipe. There's a very crappy, almost dead piece. Oh, here's another piece of 6-inch. Oh, cool. Here's an 8-inch to 6-inch coupler. So what I'm thinking is we just start with just this stovepipe. We put a screen on the bottom. We choke it down to 6 inches, which I have. It looks like I have the part for. Put a bunch of stovepipe, whatever we can find. Fill that with wood chips, light it from the top, and see if it goes. If it doesn't go, we have the option of putting it in here to see if the extra insulation will help keep this heat zone hotter and create a hotter fire and more draft. You know, I kind of don't think that's going to work. You know, this is primarily, at least, for just keeping the wall from catching on fire when we pierce the wall. The other thing is I'm not opposed to putting a fan in the bottom, and that would be easy to rig up. Just, I have various fans kicking around. I would prefer not to do that, but I'm not opposed to it, and if it works, and, you know, refinements could be made later. All right, I actually just grabbed a piece of this 6-inch stainless pipe. Another 6-inch pipe should, yes, just plug in there. I'm just gonna use this as the burn chamber. It's pre-insulated. You know, there's no need to test the separate canister thing. That's just not really part of the proof of concept. I'm just gonna stuff this piece of wire up there. Then I'll fill it with walnut shells, add a bunch of this for draft, light it, and see what happens. I don't think it's gonna be hot enough. You imagine all the air trying to come up through like this, you know, 18 inches or whatever it is of walnut shells. How fast can that air really travel up there? So I think it's going to burn slow. Here's some possible ways to deal with that. One is to create more pull. So that would happen after the burn zone. Chances are it would be like increasing the diameter of this pipe, more pipe, insulating the pipe, which I can't do because remember that after this point, this is what's heating the sauna. So I need this to be a thin wall so that the heat, you know, doesn't just, yeah. Or maybe small and then large to create a Venturi effect. So I think if I were to say, you know, run this 6-inch for a while, then maybe about where it goes outside, or after it goes outside, go to like 10 inches or something and create this speeding effect. I'm not sure. I'd have to like research Venturi effect a little bit maybe to figure that out. Okay, so those would be pulling more air through, drawing more air through, and then the other option is to push air through, probably a fan. I mean, I don't know how else you would do that, and that's probably the first thing I'm going to try, is just get this burning. We'll just let it burn, see what it does, and then in the meantime I'll run around and get something together to try to force some air, you know, turbo drive that thing and get it cranking. So let's put all this together. Don't laugh. Remember, just repeat the mantra. Proof of concept. No use wasting time making things pretty until we know whether or not the thing might work at all. Is that gonna... Let's just make this a little bigger so it fits tighter. Okay, I'm gonna shove this thing way in there so we don't need like a lot of walnut shells. So that'll be about maybe half of it full. It's close to 45. It's maybe a little steeper. Now another thing I think may have a very big effect is the fuel size and shape. So imagine, again, air trying to come through that. Just for that reason alone, this may fail without like a heavy forced air. Now imagine like 1-inch blocks of wood and all the space there would be between 1-inch blocks of wood. Or a bundle of rough sticks, right, that's shoved down there. There's going to be linear paths right through those sticks to the top where the burn zone is. Maybe it would require the use of a fan for some fuels, but not others. So if this were a system that was in regular use, I would think having little prepared bundles of like twigs or just use paper. But remember, like it's going to be a canister, so you would light the canister and then put it in. It is burning. It looks sluggish though. Let's give it a minute to get some steam. Okay, no, it's got a good draft going now. See, we have smoke though. I don't want a bunch of smoke. Creating creosote in the pipe, and you know, it's inefficient. Like you want all this smoke stuff should be burning up. That's fuel that's escaping. Look at this, we have flames almost to the top of this. We do now. Yeah, it's doing good. Here's an idea. What if the stovepipe came into the room, like in say about here, it's suddenly squished down into a broad, flat tube that's say like 2 or 3 inches thick and large. So it would actually have more volume than this pipe, which could create a Venturi effect, but it would be squished flat. So you could imagine something like, you know, 16 inches wide, 2 or 3 inches thick, that's essentially like a pipe. So you're going to have like a much increased surface area of metal to radiate heat into the room. Increase the volume of air and then probably choke it down again before going out the ceiling. Like there may be some combination of things like that, like large to small, small to large, that would create that effect and create more pull. So you know, this isn't filthy at all. It's not bad. And listen, I mean, it's burning pretty good. I wish we could see what's going on in there. But honestly, so far, like, this is pretty cool. It looks promising. I really think playing with the fuel size and quality and differences in the fuel. A lot of people do this to make biochar using wood chips, like out of a chipper shredder. Look up the Jolly Roger TLUD on YouTube. and you'll see what I'm talking about. But like standing right here, significant heat. You know, I mean, my face is very warm, so it is putting out heat. But I have a feeling if I was in a very small room, I'm pretty sure it would already be getting pretty warm in there. But listen to this. Okay, so first of all, look at that. Very clean, like basically no smoke. Listen. This thing is cranking. Another possibility would be to like pack the top 6 inches with something really loose and fast burning, right? Like small twigs or whatever, just something that's going to kick that off super fast and get that hot draft going as quick as possible so that we don't even have that initial, whatever it was, like 3 to 5 minutes of smoke. It wasn't a lot of smoke, but it was still some. I think we could get rid of that pretty easy by just fuel selection and quality. I'm thinking at this point, like a long canister is a good thing. Having a long cylinder would be more flexibility and you wouldn't have to fill it all the way. But as far as this goes, I mean, it works. Okay, so here's my sauna. Leave a space in the studs, like a big square or whatever, 16-inch studs. Put in like a metal box in there, just fab up like a sheet metal box or something. Poke this stuff through. Let's see if... I mean, that is hot. It's like I can touch it, it's not going to burn me, but I can't leave my hand there. So yeah, we're going to want like a good buffer here, probably like a metal box filled with some kind of insulation, like KO wool, one of these insulations that doesn't burn. You know what I want to do too though is I want to mess with this angle a little bit, because you think I'm outside and I have to be able to put that canister in there, so this has to be raised off the ground a certain amount, or it has to move, like, and I don't think it's going to be able to move. So I have to think about that in the design of leaving enough room to slip that canister in. But you know, a lot more of this can be inside the building, and maybe have like dig out a space under there, like if it's a deck or something, just have a space where you can slip that thing in there. It doesn't seem like an insurmountable problem, but the other thing we could do is maybe just drop this angle a little bit. And if it could still work at a lower angle, that would make it easier to be able to set up to get the canister in and out easily. I want it to be easy too, you know, I don't want it to be a hassle. Yeah, so there's some technical problems to solve. Like I need to spend time just thinking this whole project through a little bit and options. So the major problems to solve: having enough room, can this burn at a lower angle, which I think I want to try today. Listen to this. Hear that? I don't want to burn my eyeballs. I'm trying to see. I mean, that flame's reaching past this joint at least. I'm kind of assuming that if I make this horizontal, it's not going to work anymore. But that doesn't mean it won't work at all if I go horizontal across the back wall of my sauna and then curve this up. Okay, and there goes our draft. I mean, it just stopped. No more rocket noise. I have my canister. The top is open. I pack it with fuel. I put in a second screen, like a screen that fits over the top of it before I put it in, so none of the fuel can really spill out. And then this comes maybe at an angle, maybe even horizontal, and then it makes a turn and goes up. Could happen. And also, especially if there's very little smoke and we're not going to get any creosote buildup, we could come in, you know, even horizontal, make an L right away to create draft, and then go across and then go back up. Again, just trying to expose as much of this bare stovepipe as possible to let that heat get into the room. Proof of concept wise, I feel already like I could just build my sauna, leave that box between some studs or whatever, just leave a big space to work with, and then start, you know, figuring something out. The other thing I'm thinking of doing is just taking a bunch of tall fence posts, maybe like 6 of them, just pound them into the ground in a rectangle, wrap it with blankets, put a blanket over the top, and figure out some way to... I have like a stovepipe thing for a tent. It's like this fabric that's fireproof, so you can sew it into the side of a canvas tent. So I could potentially like put that in a piece of canvas and literally make a little fabric canvas sauna. And if I can heat that, you know, around near the size of the sauna I want to build, then obviously it'll be easy to heat the sauna. So let's drop this back down and see how that draft picks back up, because it's pretty much toast. Like, it's not pulling at all. There's literally a space all the way to the bottom now, packed with chunks of hardwood. You know, I think it would probably burn long enough to do a sauna. Even if it didn't burn long enough to do a sauna and then cut it off and save the charcoal, that might not work out. But I still want the option, and I think this was a success. Proof of concept proved.